When Space Shuttle Challenger launches on a January morning in 1986, a key engineer is sure a catastrophe is coming.
We've got to stop the flight.
He thinks the ship is going to explode.
And liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
73 seconds later, disaster strikes. 7 astronauts die in front of their families and millions of television viewers.
Our hearts were shattering much like.
Was tragedy inevitable, or could the shuttle and its crew have made it into space?
Could they have made it? That question haunts me.
North America, Florida. January 28th, 1986. 8:08 a.m. 1.5 hours to liftoff. At Kennedy Space Center, final preparations are underway for the most anticipated space mission since the glory days of the Apollo era. Thousands have budget cuts and a loss of public interest. The shuttle has never made good on its promise to provide a routine bus service to space. Just as the report states, the trail of exhaust has a very unusual shape. The column of smoke displays a dramatic zigzag, then returns to vertical just moments before the astronauts were killed. Is this smoke trail evidence that the shuttle was hit by a strong side wind during its ascent? Initially, it's hard to make the theory stand up. In the hours leading up to liftoff, NASA's meteorologists sent up several weather balloons to check for strong crosswinds. Their data indicates there was nothing unusual. But Childs isn't convinced the weather balloons got it right. Closer examination reveals the balloons had drifted over 64 kilometers downwind during their ascent. It's unlikely they would have experienced the same weather conditions as Challenger. Further intriguing evidence comes from the telemetry that monitors the ship's direction. At 58 seconds into flight, Challenger's main engine nozzles suddenly alter their thrust angle by 2 degrees. The large adjustment is an automated reaction to keep the craft on track and suggests that some external force could have been pushing Challenger off course. What's more, the shuttle's lateral accelerometer, a device that measures sideways movement, throws up a surprising reading at exactly the same moment. There's a sinister gap in the data. This could mean one of 2 things. Either there was a glitch in the telemetry, or the lateral acceleration was so violent that the reading went right off the scale. If the second of these 2 options is the truth, it could be the key as to why Challenger blew apart, taking with it the lives of 7 astronauts. Jim Childs believes he's close to finding out the truth behind what may have caused the Challenger disaster. The telemetry indicates that the shuttle was knocked violently sideways at 58 seconds into the flight. He returns to the image of Challenger's smoke trail. And sure enough, at 10 kilometers, the smoke trail has an extreme dogleg to it. The zigzag could be evidence of a fast-moving narrow layer of air, a jet stream, tracking rapidly east. The report states that just 30 minutes before liftoff, a commercial jet flew above the launch site. As it did so, the Boeing 757 was hit by a headwind of over 300 kilometers per hour. It's a shocking revelation. It looks like Challenger must have passed through the same layer of air as it climbed towards space. As it entered the jet stream, it would have been hit broadside with a force equivalent to Hurricane Katrina. Now, by rewinding the events of that ill-fated flight, and by following the evidence uncovered during the extensive investigation, we can finally reveal exactly what caused the Shuttle Challenger disaster 73 seconds after liftoff.
4, 3,
73 seconds to disaster.
1.
The solid rocket boosters ignite. Inside the right booster, the O-rings have been hardened by the freezing temperatures and are unable to keep the lowermost field joint sealed. They start to burn away.
And liftoff. Liftoff.
As superhot gases escape, small pieces of aluminium slag from the rocket fuel build up and block the hole, preventing a catastrophe on the launch pad. 15 seconds to disaster, as Challenger enters a fast-moving yet very narrow jet stream. It is shaken violently. The aluminium slag is dislodged. Almost immediately, a flame appears on the right solid rocket booster. Eight seconds to disaster. With blowtorch intensity, the flame penetrates the external tank, and liquid hydrogen starts to spill out. 1 second to disaster. The attachment between the booster and the tank breaks free, and the entire bottom section of the tank gives way. The Inferno thrusts the hydrogen compartment upwards into the oxygen-filled container, just as the nose of the booster crashes into the top of the external tank. Nearly 2 million liters of fuel combust instantaneously. The shuttle breaks apart.